Rubik's Cube Methods Episode 6, Roux.
Hey everyone, my name is Vic, and today in this video, I'm going to teach you how to solve the 3x3 Rubik's Cube using the Roux method. This tutorial is not for beginners. First, I'll be going through an overview of the steps. Step 1, first block. First block is where you create a 1 by 2 by 3 block on the left side of the cube. Step 2, second block. Second block is where you create another 1 by 2 by 3 block on the right side of the cube. Step 3, CMLL. CMLL stands for corners without the M slice. So we're going to ignore the M slice for this step and we're going to solve the corners. First we orient the corners and then we permute the corners using a total of 9 algorithms. Step 4, LSE, is divided into 3 parts. The first part, 4A, is called EO, where we orient all of the edges. Step 4B is where we solve the UL and UR edges. And lastly, step 4C is where we solve the last 4 edges. Just to make things a bit easier, we are going to orient the cube so yellow is on top and orange is on the front. Now in first block, there are a couple of ways to do this. The first method I'm going to show you is where you solve the DL edge. So if you're wondering, what is the DL edge? Well, the DL edge is the edge that goes in the down left spot. So for example, this white green would be our DL edge, and we can solve it by doing F prime, L. After solving our DL edge, we need to solve the 2 pairs that go beside it. I can solve mine by solving these 2, like that, and these 2, like this. In the Roux method, we don't rotate, because if we would ever need to rotate, we would instead just use the M slice to solve the pieces. Starting off with the corner in the upper layer, with the white facing the sides of the cube, and the edge in the bottom layer. If you see that the top color of the corner matches the front color of the edge, you want to line the corner up so that it's diagonally on top of the edge. So it's diagonally on top. Then you want to bring the edge up with M prime, move the pair out of the M slice with either U or U prime, then put the M slice down again with M. Now if you get the exact same case with the top corner color matching the color of the edge facing the back, you put the corner diagonally on top of the edge so that the white is facing the sides, not the back. Then you bring the edge up to match the corner with M, move the pair out of the M slice with either U or U prime, and fix the M slice with M prime. After that, you can go and insert the pair. The next case is if you see that the top color of the corner does not match the front color of the edge. So orange does not match with green. You want to put the corner in the far back with the white facing the side and not the back. Then you bring the edge up with M2 to solve it with the corner. Then move the pair out of the way with either U or U prime, and then fix the M slice with M2. If you get the same case, but with the edge in the back, and the top color of the corner does not match the back color of the edge, put the corner in the front with white on the side and not in front. And then bring the edge up with M2 to solve it with the pair. Move the pair out of the way with either U or U prime, and then fix the M slice with M2. When inserting Roux pairs, we don't ever need to rotate. So if you find yourself rotating to insert a pair, remember that there is always a way to insert it without rotating. If you have a pair that you need to insert into the front, and the front color matches the center color, you can insert it with either F prime or LY prime, U prime, LY. If you have a pair that you need to insert into the back, and the back color matches the center color, you can insert it with either B or LY U LY prime. If you have a pair that you need to insert into the front, and the front color does not match the center color, you can insert the pair with L prime, U, L. If you have a pair that you need to insert into the back, and the back color does not match the center color, you can insert it with L, U prime, L prime. Now moving on to when both the corner and the edge are in the upper layer, you can hide the corner, then move the edge over, so when you bring the corner up, the two of them will solve. You can also hide the edge, then move the corner over, so when you bring the edge up, the two of them will solve. Note that doing an R wide move or L wide move is the same as doing an M move. I would even recommend R wide moves or L wide moves over M moves, so you don't have to regrip your fingers so much. For example, say that your thumb was already on the bottom layer. Now instead of regripping your thumb to do M2, you can instead keep your thumb there to do R wide 2. However, doing wide moves also affects the outer layer that it's also turning, so make sure when you do this you won't be affecting the outer layer in any way. Tip: if you get a bad case, you can either reorient the edge or the corner to make it better. There are other techniques to making a block, such as line block building. In line block building, you solve the middle layer edges first, and then you solve the bottom layer edges. Example, I will solve this edge with an F prime, then I'll solve this edge with a B. So there we have the line in the middle, and then we just need to complete the line on the bottom layer. So I can solve this corner with this edge by moving it right here and then doing R wide, U, R wide prime. And then I can move the block here, and that also shows me that this corner is connected to this edge, so I can just put in the top layer and then reorient it so that it solves, and then fix it, and there we go, we have a block. You can also do this in reverse with the bottom layer pieces first and then the middle layer edges. There's also half line block building, where you solve a bottom layer edge to a corner, like this, then solve the middle layer edge, and then connect the two, or the other way around, and then you can solve the remaining pair. If the corner is in the bottom layer with white facing the sides and the edge is in the top layer, and the top color of the edge matches the front color of the corner, you can move the edge so that it's diagonally on top of the corner, then move the corner up to solve it. Do the same from the back. If the corner is in the bottom layer with white facing the side and the edge is on the top layer, and the top color of the edge does not match the front color of the corner, put the edge in the back and do an R2 to solve, and then you can insert. You can do the same from the back. I highly would not recommend solving the pairs before solving the DL edge, as it can get quite messy. For example, and that was a pretty easy case. Second block will be pretty brief, as it's relatively the same as first block, except you just don't want to do any moves that will wreck the first block. So I'll be doing 3 examples. So first I'll solve the DR edge, and instead of just bringing it down like this, I noticed that the corner goes with it, so instead I can just bring the corner out of the way, and when I do an R, it will reorient the corner, and that gives me a really nice case. So I can just insert the pair. And then here I get another really nice case where I can just put the corner in the back, bring the edge up, move the pair out of the way, fix everything, then insert into the back. For this example, I'm going to solve my DR edge with this corner, like so, and then I can just attach it to this edge with R wide, U, R wide prime, and then fix it. And then, oh, I see that these two colors don't match, so I put the corner in front, then do M2, and then solve. For this example, I can solve these two like this. Then I can match this block with this block. And then I can solve these two pieces. In the full method, there are 42 algorithms in total for CMLL, but today we're going to learn the two-look version of that, which consists of 9 algorithms. 7 of those algorithms orient the corners and 2 of them permute the corners. For EO, the first case we're going to learn is this case, called the arrow case. You might be thinking, why arrow? However, if you position the free pieces on top so that they're opposite of the edge on the bottom, the shape it makes resembles an arrow. Now the arrow case comes in 2 forms. If the misoriented edge on the bottom is in the DF position, down front, you want to position the free edges on top so that one is in UL, one is in UF, and one is in UR. You now want to do this trigger, M prime, U, or U prime, and then M or M prime. Whichever one works. As you can see, the edges are now oriented, so either white or yellow is facing the top or the bottom. If the misoriented edge on the bottom is in the DB position, down back, you want to position the free edges on top so that they're in UL, UB, and UR. Now you do this trigger, M, U, or U prime, then M or M prime. Every EO case is reduced to the error case. Now you can only get an even number of misoriented edges. So if you get an odd number of misoriented edges, then you've surely done something wrong and you have to go fix whatever you did wrong. Usually it has something to do with solving the first 2 blocks incorrectly. After solving edge orientation, we are now going to solve our UL and UR edges. For us, that would be yellow-green and yellow-blue. First, you will insert both edges into the bottom layer. For the first edge, you can simply put it in with M2. And for the second edge, if you want to insert the edge into DF, you can do M prime, U2, M. And if you want to insert the edge into DB, you can do M, U2, M prime. And once you have both of them in the bottom layer, you move the corners that solve with the edges so they line up with the edges. So, like this. Now, you actually want the front color of the corners to not match the front color of the DF edge. So when you bring the edges up with M2, they will solve. So for this last step of solving the Rubik's Cube using the Roux method, there are two groups of cases. One is L3 and one is L4E. L3 just means the last 3 edges, and L4E means last 4 edges. This step can be solved intuitively, and I'll explain to you how to do it right now. In L3, 1 out of the 4 edges in the M slice will be solved. So this one, white-red, is solved. I want you to completely ignore that edge because it's irrelevant. I want you to focus on the 3 edges that aren't solved. You will find 2 edges that are closely related to each other. For example, yellow-red is closer in relations to yellow-orange than white-orange. Your next task is to bring yellow-orange into the top layer and swing it around so that it solves with yellow-red and then fix the M slice. So I can bring yellow-orange into the top layer with M prime, swing it around with U2 to solve it to yellow-red, and then fix the M slice with M. So really, all you need to do is find 2 edges that share one color. For example, yellow-red and white-red. Match them through a series of U2, if needed, and bring those 2 edges into the upper layer, do a U2, only if needed, and then fix the M slice. So for example, yellow-orange, white-orange, they're already connected, so just bring them into the top layer, U2 to solve them, and then fix the M slice. L4E really follows the same concept of doing U2 to solve the edges, if needed, bring another 2 sets of edges into the upper layer, do a U2 again to solve the other pairs of edges, and then fix the M slice. So this one, they're already kind of connected, so just do a U2 to solve them, then bring the next pairs of edges up into the upper layer with M2, then swing them around with U2, and then fix the M slice with M2. For example, again, they're already connected, so you just bring them into the upper layer, do a U2 to solve them, then bring the next sets of edges with a M2 into the top layer, then do a U2 to switch them around, and then fix the M slice. Now this case, called the dots case, it looks really strange, but really you follow the same rule of thumb. So first, we need to find 2 edges that share something in common, like yellow-orange and yellow-red, so we can swing them around to get them solved, and then we can put them in the bottom layer and move the next set of edges to the top layer. Do another set of moves to swing them around, and then we get the case we had before, and we call that the columns case, and then we just switch these 2 around, bring the others into the top layer, switch them around, and then fix the M slice. So now I'll be doing a walkthrough solve of the Roux method. So first block, I will solve my DL edge, but instead of just putting it straight through, I will take out the corner, like that. Then I will solve this pair, like that. And then I see this pair, which is what I need. So I can bring the corner in the top layer and do a U2, bring the edge up, and then solve them like that. So this is pretty bad for any type of block building, so I'll just put that in. Probably insert this edge like that, and then do this block. And then I have this case, which I can do like this. And then we have the T case, so we can go like this to orient the corners, and then we can do a Y perm to permute the corners. And then we have this case, get the arrow And then we can put this in the bottom. That will be UR. This will be UL. And then we can put green in front because it's opposite of this color. Go like that. And then we can solve like the corners so that we now know exactly what we're doing here. So this edge is solved, so we can go like this. U2, M2, done. Thank you guys so much for watching this Roux tutorial. I know it's been a long time, but I am back now. I hope you guys enjoyed this video and learned from it. If you have any questions, please comment them down below and I'll do my best to answer them. I'll see you guys next time.